Hi, good afternoon. C3. Apologize, I couldn't be in group today, so I wanted to make this video to talk about one particular LI that I hold true and dear and probably do my part for the day, even though I'm not with you today. And that's the NFkB, Fos, and Jun LI. So we all agreed Wednesday that NFkB is the master controller of the inflammatory response. And I was going to talk about how it does that. So NFkB, think of this as your NFkB. NFkB hangs out in the cytoplasm, and it cannot do anything until it goes into the nucleus. And when it gets into the nucleus, it causes inflammation and all those things that we looked at. But how does it get there? And what prevents it from going to the nucleus? You know, how come we don't have inflammation going on all the time? Well, that's thanks to another protein called IKB. And IKB just means inhibitor of kappa B. So think of this as your IKB. IKB is on top of NFkB, and it prevents it from going into the nucleus to cause inflammation. Well, when we have a signal that starts the inflammatory process, like we looked at toll-like receptors, for instance, they'll activate through like MYD88. That's going to come in, cause phosphorylation of IKB. So think of this as a phosphate group put on top of IKB. So then you have this process in the cell. When IKB gets a phosphate group, you have a protein called ubiquitin. At this point, if the group wants to put this up on the board, ubiquitin is a very, very important protein that we need to know. So you can put that on the board. But anyway, once ubiquitin realizes that there's a phosphate group on top of IKB, it's going to come and attach a series of ubiquitin proteins. And that process is called ubiquitination. So think of this as your ubiquitin. And so you have many of those. That means you've marked this protein for degradation. So you have a bigger protein called a proteasome. It's like a degradation protein. It's going to recognize these ubiquitination proteins and say, I have to get rid of that. I know Dr. Akbar is running right now because he doesn't want us to say, the protein says I'm going to get rid of that. But that's what happens. It recognizes the ubiquitination and it knows I got to get rid of that. So the proteasome is going to come and degrade the IKB, take it away, and now you have NFkB by itself. NFkB will go into the nucleus of the cell and cause inflammation. So that part is pretty much clear. I think so. Well, the other part is, well, what does Fos and Jun do? Well, NFkB causes inflammation through Fos and Jun. It probably does this through other ways too, but Fos and Jun are very important just because of the clinical relevance. So I guess one of the things about PCC is we have to look for information on our own. And maybe when you looked up Fos and Jun, you couldn't find the information. But just to make it really easy, Fos is one protein. Jun is another protein. When they come together, they make a protein called AP1 transcription factor. AP stands for activator protein. Well, the activator protein that's formed by Fos and Jun is what creates the inflammation cascade. It's what acts as an inflammatory switch, for instance. It has a lot of functions in the cell, but one of it is that it creates the inflammatory response. And so NFkB usually works through the AP1 protein. But so if you look that up, you couldn't find Fos and Jun independently, but if you look up AP1, you'll see what I'm talking about. And maybe, at this point you want to write AP1 transcription factor, activator protein 1, and so we can review that. But the other clinical thing, and this is the last thing I'm going to say, the other clinical thing is that Fos is a proto-oncogene. Proto-oncogene means it has it can become an oncogene. That means it's not cancerous at all, but when you do mutation or you constantly activate it, it can become an oncogene and become cancerous. And this explains why constant inflammation can cause cancer. because you have this Fos gene, which is a proto-oncogene. Constant stimulation can make it an oncogene, and then that's how you get cancer. And again, sorry to pick on you, but if we don't know what pro-oncogenes are and oncogenes are, these are very important genes in the pathogenesis of cancer, for instance. We can put them up on the board, and then we can talk about them next time. Thank you so much. I promise I'm going to be quiet from now on till the end of group. And have a great Thanksgiving, and I'll see you in about a week. Cheers.